Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2017, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're looking at OCR November 2017 paper 5, higher tier. Now that's the non-calculator paper. Question 1. The diagram shows a circle centre O. We need to write down the mathematical name of line A and the shaded region B. Okay, well line A is just a straight line touching the circle, so that one we call a tangent. And the shaded region looks like an orange segment. I'm going to call it a segment. I suppose it's actually the minor segment, isn't it? But I think segment will get the mark. Question 2a. Write down the next term in each of these sequences. Okay, so what sort of sequence is sequence 1? Now you can see that it hasn't got a common difference. The first one is 0 and the second one is 1, so it isn't a linear sequence. This is actually a Fibonacci type sequence, because if you look at this one added together it gives you that. These two added together is going to give you that one, and then these two added together is going to give you that one, and so on. So you're going to get the next sequence, next term in the sequence, by adding the two previous ones together. So by adding 5 and 8 together, I'm going to get my next term in this sequence. It's going to be 13. With question 2, you can see you can get the next term by multiplying the previous one by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. I think that one I should read 64. And then so 64 times 2 is going to be 128. Okay, part B. Write down an expression for the nth term of the sequence below. 15, 12, 9. Okay, now this one does have a common difference. It's got a common difference of -3. It's going down by 3 each time. So the nth term is going to be of the form -3n. So whatever that difference is, that's what's going to be the coefficient of n in the nth term. But -3n, if n is 1, then -3n would be -3. So what would we have to add on to -3 to get 15? It would have to be 18. So 18 minus 3n would give me a first term of 18 subtract 3 of 15, and a second term of 18 subtract 3 times 2, which would be 12. So that is my nth term. 18 minus 3n. Question 3. Andrew is thinking of a number. It's between 1 and 150. It is 1 more than a square number. It's 3 less than a cube number. It is not a prime number. What is Andrew's number? You must show your reasoning. Okay, well I think the way to answer this is to start listing out some values. Okay, so I'm not going to write out all the numbers between 1 and 150, but I can start writing down the square numbers. one more than a square number. So the first square number is 1 squared, which is 1, plus 1 is 2. So the first question so the first term, which is 1 more than a square number, is going to be 2. And then after that, 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. Then I'm going to get 25 plus 1, which is 26. 36 plus 1, which is 37. 49 plus 1, which is 50. 64 plus 1, which is 65. How are we doing? That's 8, isn't it? 9 is going to be 82. Then I'm going to get 101. 11 squared is 121 plus 1 is 122. Then 12 squared is 144 plus 1 is 145. Okay, and then the next one's going to be bigger than 150, isn't it? So I can stop there. Okay, so they're all the one more than square numbers. Let's do the same with cube numbers. 1 cube is 1, take away 3 is going to be outside the range, but 2 cubed is 8, take away 3, that's going to be 5. 3 cubed is 27, take away 3 is 24. 4 cubed is 64, take away 3 is 61. 5 cubed is 125, take away 3 is 122. And then 6 cubed is going to be too big, isn't it? So they're all the ones I need. Okay, so which ones are in both lists? So you can see I've got a 5 in both numbers, here and here, look, and I've also got a 22 in both, 122 in both numbers. So 5, can that be the solution? Well, no, it can't be 5 because I'm told it's not a prime number and 5 is prime, so it's not going to be that one. So it must be 122. So 122. Okay. You must show all your reasoning. I think I have, haven't I? I've listed out the. Well, just let me write that down. That's n cubed minus 3, isn't it? So I've listed out all the 1 more than squares, and I've listed out all the 3 less than cubes, and I found the ones that match, and I've crossed out the ones that are not prime. I think that's fine. Question 4. Factorise x squared minus 43 squared. Now this is just simply the difference of 2 squares, isn't it? I've got 2 squares and I'm subtracting them from each other. So you should know that that factorises into a double bracket. So the square root of x squared is x. So we're going to have an x and an x there. And the square root of 43 squared is 43. So I'm going to have a 43 here and a 43 here. And one's going to be plus and one's going to be minus. Okay, that's that. So calculate 57 squared minus 43 squared. Odd question to do without a calculator, but look, we've just done the difference of 2 squares up here, so perhaps we can use that to help us here. Let's make x 57. Well, we've already got 43 in the bracket above, so if I replace my x here and here with 57, then you can see it's going to be 57 squared, sorry, 57 plus 43 multiplied by 57 subtract 43. And it just so happens that 57 plus 43 is a nice number. It's 100. And 57 take away 43 is not such a nice number, but isn't that bad. It's 14. So 100 times, so that's going to be times, and isn't it? 14. 100 lots of 14. 1400. 1400. Question 5. Here is a coordinate grid, and part A says draw the image of triangle A after a reflection in the line y is equal to -1. Okay, so where is the mirror line y is equal to -1? Well, y equals -1 is going to be a horizontal line passing through y is equal to -1. It's going to be this line here. I'll just draw that on. So this is my mirror line. Okay. So that is the line y is equal to -1. So I'm reflecting triangle A in that mirror line then. So let's take each of the corners of my shape. So I've got one there, one there, one there. So the first one is 1, 2 units away from the mirror line. So its image is going to be 1, 2 units away. It's going to be here. And so is the one there. And the other one is 1, 2, 3, 4 units away from the mirror line. Sorry, 1, 2, 3, 4, 5 units away. So its image is going to be 5 units away. It's going to be down here. Okay, and once you've got your corners, you can then join them up with a ruler. I don't recommend reflecting the lines. Always reflect the coordinates, the corners. It's much easier. Okay. And part B says, describe fully the single transformation that maps triangle A onto triangle B. Okay. So we're mapping A onto B. Now you can see that A and B are different sizes, and the only transformation you need to know about that changes side is enlargement. So if I was going to fully describe this transformation, I would have to say it's an enlargement, and that would be enough to get my first mark. So it's an enlargement, correctly identifying the type of transformation. Now, in order to fully describe an enlargement, you need two things. You need the center of enlargement and you need the scale factor. Now, you can work out the scale factor just by measuring two matching sides on your shape. So if I look at triangle A, this bottom line here is 2 units in length, and its matching one on B, this one, is 1 unit in length. So the scale factor has changed it from 2 to 1. In other words, it's half, isn't it? So I'm going to write that down for my second mark. So it's an enlargement scale factor of 1/2. And the final piece of information you need to write down is the center of enlargement. Now you can do that by just drawing some ray lines on your diagram. So I'm just going to line the ruler along matching points on my object and image. I've started with the top corner there. I'm going to draw a thin, faint line, and then I'm going to do the same with these 2 points here. And you should find that they converge on a particular point, which I think is this one here, isn't it? So that's the coordinate 5, 7. And that's going to be my center of enlargement. Center 5, 7. That's all we need to say. So enlargement, scale factor, half, center, 5, 7. Part C says, complete this statement. A rotation of 180 degrees around 0, 0 has the same effect as an enlargement by scale factor with a center of enlargement. What? Okay, so a rotation of 180 degrees around 0, 0. So basically what you're doing is you're not changing its size, you're just flipping it around, and it's going to end up being upside down, isn't it? So let's just do a quick sketch of that. If you had like a center of rotation here and a triangle like this, and you rotate it at 180 degrees, you're going to get your triangle appearing down here, aren't you? So it's going to be like the same size but inverted. So what is that the same as? That is the same as an enlargement centered on the origin, scale factor -1, isn't it? There's going to be a scale factor of -1 with center of enlargement 0, 0. Question 6. This rectangle has a length of 4x minus 5 centimeters and a width of x plus 3 centimeters. We're told that the perimeter of the rectangle is 46 centimeters, and we need to calculate the area of the rectangle. Okay. So we've got two things to do here. First off, we're going to form a linear equation in x using this perimeter fact here. Hopefully then that tells us what x is, and we can then go on to calculate the area of the rectangle after that, can't we? Okay, so let's do the perimeter thing first. Now the perimeter of the shape is the distance all the way around the shape. So if you start in one corner and you kind of stroll down one end, around there, and up there again, how far have you gone? Okay, so basically we're just going to add the four sides of the rectangle together. So my perimeter is going to be equal to 4x minus 5 plus x plus 3 plus another lot of those, isn't it? So plus another 4x minus 5 and another x plus 3. Okay, so then collecting like terms together. 4x, x, 4x and x, that adds up to 10x. And negative 5 plus 3 minus 5 plus 3 is going to be negative 2, isn't it? No, sorry, negative 4. Okay, so my perimeter is 10x minus 4. But we were told earlier that the perimeter was 46. So I can put that in there for p. So you can see now I've got a linear equation in x, which should be quite straightforward to solve. So taking this to the other side, or adding 4 to both sides, I'm going to get 50 is equal to 10x, and then dividing both sides by 10, I'm going to get x is 5. Okay, so now I know what x is. I can then move on to do the second part of the problem. Let's just find a numerical value for the length and the width then. So if x plus 3 is the width, then 5 plus 3, that's going to be 8 now, isn't it? Okay, and then 4x minus 5, if x is 5, then 4x is 20, take away 5 is 15. Okay, so actually I've got a rectangle of length 15 and width 8. So then its area is just going to be 15 times 8. What's that? 10 8s are 80, 5 8s are 40, so that's 120 then, isn't it? Don't forget units, centimeters squared. Question 7. Naomi is given a 10% pay decrease. Her new wage is £252 per week. What would her weekly wage be if instead she had received a 10% pay increase? Okay. So I tend to do percentage change questions using this triangle. Final, original, multiplier. Just a way of remembering what you have to divide with what or multiply by what in these percentage questions. So I'm just going to work out what the final, the original and the multiplier is for the first part of the question, and then sub it in to my equation. Okay, so let's have a look through here. So Naomi's given a 10% pay decrease. That is a multiplier then of 100% take away 10%, isn't it? 100% take away 10%, 10% decrease. Now that is 90%, which as a decimal is 0.9. Okay, her new wage is 252. Okay, is that the final? Is that the original? Well, final comes after the original, and it's a new wage. So she had an old wage, which was the original, and we now have a new wage, which is the final. So that is 252. So it's the original we're trying to find then, isn't it? Okay. So looking at our little triangle over here, cover up the one you want to find, which is the O, stick your thumb on it, and then it's going to tell you what to do with the other two. So original is going to be my final divided by my multiplier, which in this case is 252 divided by 0.9. Okay. 0.9s into 252. Can we do that? Does it actually even divide by? 0.9. Well, if I'm just going to times top and bottom by 10 just to get rid of the decimal. 2520 over 9. Now, is 2520 divisible by 9? There's a trick, isn't there? If you add all the digits up and you get a multiple of 9, then it divides by 9. So 2 plus 5 plus 2 plus 0, that adds up to 9. So yeah, it's going to divide. So how many times does it go in? So 10 nines are 90, so 100 nines are 900. So 200 nines are going to be 180. So it's going to be 200 and something, isn't it? So 1,800 away from 2520. That's another 720 I need to find. 9s into 720. 9s into 72 go 8 times. So I think it's going to be 80, isn't it? So 280. So 280 is how many times it goes in. Right, so that is the original salary then, isn't it? £280. So what would her weekly wage be if instead she received a 10% pay increase? Okay. So we're going to go back to our triangle again. We've got a new problem here, haven't we? So second triangle, final, original, multiplier, and then work out what F, O and M are now this time. Okay, so this time we're starting with the original because we know it's 280 now, so that's going to be that one there. So that's 280. The final is what we want to find. We want to know what her weekly wage would be if she'd received a 10% pay increase instead. So that is the one we're trying to find. And the multiplier this time, 10% pay increase. 10% increase, if you've got 100% and you add on 10%, that's 110%, which as a decimal is 1.1. So that's going to be my multiplier, 1.1. Okay, so then coming back to the triangle, cover up the thing you want to find. This time I want to find the final. It tells you what to do with the other two. Final equals original multiplied by multiplier. So final equals original times multiplier, and that is going to be 280 times by 1.1. Okay, how do you multiply by 1.1? So that's 280 and a tenth of 280. A tenth of 280 is 28, so 280 plus 28, that's going to be 308. So that is the final wage then, isn't it? She would have got £308 if she'd have had a 10% increase and not a 10% decrease. I don't know why she's given a 10% decrease. That's rubbish. Question 8. The angles in a triangle are in the ratio of 1 to 2 to 3. Show that the triangle is a right angled triangle. Yeah, okay. So actually this is a dividing by a ratio question, isn't it? So all the angles of a triangle add up to 180 degrees. So what you're doing is you're dividing 180 in the ratio of 1 to 2 to 3, aren't you? So if it's in a ratio of 1 to 2 to 3, that's 1 plus 2 plus 3, that's 6 parts, isn't it? Okay, so you're dividing 180 into 6 parts. So 180 divided by 6. 6 is into 180, 6 into 18 goes 3 times, that's 30, isn't it? So each share is then, or each part is worth 30. So if I take my original ratio 1 to 2 to 3 and I multiply it up by a factor of 30, I'm going to get 30 to 60 to 90. Okay, and look, there's my right angle there on the end then, isn't it? That's my 90-degree angle. Okay, so I suppose let's put the degrees in there. Therefore it's a right angled triangle. Let's just state the conclusion. Okay, now the hypotenuse of the triangle is 15 centimeters long. Calculate the length of the shortest side of the triangle. Okay, so we've got this triangle, which is 30, 60, 90. So let's put the right angle there. So let's mark on the 30-degree angle, which is going to be the smaller one up here, 30. And we're told that the hypotenuse, which is the longest side, or the side opposite the right angle, is going to be 15. And we want to calculate the length of the shorter side, which is this one over here, isn't it? It's the one opposite the 30-degree angle. Okay, so if I was using trigonometry here, I've got an angle of 30, I've got the hypotenuse, and I want the opposite. So if I've got the hypotenuse and the opposite, and I don't want the adjacent, then SOHCAHTOA, S-O-H-C-A-H-T-O-A. I don't know how you remember it. Which one am I using? I'm going to be using sine, aren't I? Sine is equal to opposite over hypotenuse. So the sine of 30 is equal to the opposite, that's the one we want to find, divided by the hypotenuse, which is 15. So that means what we're looking for then, our unknown angle then, is going to be 15 lots of sine 30. Okay, but this is the non-calculated paper, you cry. How are we going to work out what 15 sine 30 is? Well, sine 30 is one of your exact values that you're meant to remember. So there's a whole table of these that you just need to commit to memory or know how to derive for yourself. And from that table, you should recall the fact that sine 30 is a half. So actually, our missing side then is going to just be 15 times a half. So that's going to be 7.5. Okay, job done. Question 9. There are a total of 250 men, women and children on a train. The ratio of men to women is 4 to 5. The ratio of women to children is 10 to 7. How many men are on the train? Okay, so we've got a 3-part ratio, but we've been given it in two kind of ways, and we have 2 parts. So if I was trying to work out what the overall ratio of men to women to children were, then I've been given men to women as being 4 to 5, and I've been given children as 10 to 7. Okay, but we want to kind of create a ratio of all 3 together. Now notice from here to here, 5 to 10, that's times by 2, isn't it? So that's twice as big. So if I take this whole ratio and double it up, 4 to 5 would become 8 to 10, wouldn't it? So that means I can put if I multiply that 5 by 2 and get 10, I'm going to also multiply this 4 by 2, and that's going to give me 8. And that kind of completes the ratio. I've got a ratio of 8 to 10 to 7, now haven't I? So we've got another dividing by a ratio. Now I've got a ratio of 8 to 10 to 7, and I want to divide it into 250 people. So again, how many parts have I got? 8 plus 10 plus 7, that's 25 parts. And so I want to divide 250 into 25 parts. So that gives me each part is 10 then, isn't it? So then if I take my overall ratio of 8 to 10 to 7 and I multiply it up by a factor of 10, that's going to give me 80 plus 100, or 80 to 100 to 70. So they're going to be 80 men, 100 women and 70 children. Just double check, 80 plus 100 plus 70 adds up to 250, so that's all looking good. So I'm saying there must be 80 men on the train. Okay, so that's 80. Question 10. ABCD is a quadrilateral. We're told that AD equals AB and CD equals CB. We need to prove that angle ADC is equal to angle ABC. Okay, so I've got my basic diagram here of the shape, the quadrilateral. It looks a bit like a kite, and I think that's probably what we're trying to prove here, isn't it? But we're not told it's a kite, so we can't use the properties of a kite to answer this question. We've got some extra information that isn't on the diagram. So AD equals AB. Let's just mark that on. So AD, which is this side, is equal to AB, which is this one. And we're told that CD equals CB. So CD equals BD, CB, sorry. And then we need to prove that angle ADC, this angle here, is the same as angle ABC, this angle over here. I have to show they're the same angle. How can I do that then? Now, you can clearly see that this is a kite, so those angles should be equal, shouldn't they? But it's asking us to prove it. So we need to use like another rule or fact to derive this from. So we can use the fact that if I take a ruler out and I draw a line from B to D, what I'm doing is I'm effectively turning this quadrilateral into two triangles, aren't I? But not just any old triangles. These are particular types of triangles because they are triangles with two equal sides, aren't they? So this ADB is a triangle which we call an isosceles triangle, isn't it? So that's an isosceles triangle. So this angle here, so this angle in here, look, should be the same as this one over here. And DCB is also an isosceles triangle, so the base angles of that one should be equal. So that one should equal to that one. And then we can show that those two things added together are going to be equal to the other two things added together. I think that's how we're going to go about proving it. Just need to write that down mathematically. So I'm going to say that triangle ADB is isosceles. So base angles ADB are equal to ABD. Okay, so those two angles are equal. And we can also say that triangle CDB is isosceles. So base angles, what we got this time, CDB is equal to CBD. Okay, so those two base angles are equal, and those two base angles are equal. But then we can say that the angles that we want, now we can say that angle ADC, well, angle ADC is going to be those two angles added together, then, isn't it? So it's going to be angle ADB plus CDB, and we can say that ABC, angle ABC, is equal to the other two added together then, so that's angle ABD plus CBD, like that. Okay, so we've said that angle ADC is this one plus this one, which are over here and over here, and we're showing that the second angle, this one and this one, are this angle and this angle, look, and they're equal to each other, so therefore these two angles must be equal to each other. So ADC equals ABC. Now, as an alternative way of doing this, you could have instead divided it the other way. You could have divided it that way and then looked to show that you had two congruent triangles because you know that that side equals that side equals that side, and that side is common to the two triangles, so you can show that they're two congruent triangles, so that one and that one must be equal. So that's an alternative way of doing it. Either way would be fine. Question 11. Amelia buys a new car. The expected future value of this car in V pounds is given by V equals 16,000 times 0.75 raised to the power t, where t is the age of the car in complete years. So part A says, write down the value of the car when new. Okay. Well, when the car is new, t is going to be equal to 0, isn't it? Times 0, because there'll be 0 completed years. So my formula then is going to be V equals 16,000 times 0.75 to the power of 0. Okay? And anything raised to the power 0 is just 1, isn't it? So that's going to be 16,000 times 1. And 16,000 times 1 is 16,000. So actually that's not so hard, is it? Okay, part 2 says write down the annual percentage decrease in the expected value of the car. Okay, so basically you're repeatedly multiplying the value by 0.75, aren't you? Okay, which is 75%. So if you're multiplying through by 75% in the percentage decrease question, it means that you're decreasing by 100, take away 75. It's going to be a 25% decrease, isn't it? Okay, so that's 25%. Because if you've got 100% and you take away 25%, that is 75%, which is 0.75 as a multiplier. Okay, so it's a decrease of 25%. Show that the expected value of the car when 2 years old is £9,000. Okay, so when t is equal to 2, you are going to be working out V, which is 16,000 times 0.75 to the power 2. Now, I'm not going to work out what 0.75 to the power 2 is. I think I'm just going to do this as a repeated percentage change. So I'm going to times it by 0.75 and times it by 0.75 again. I think it's going to work out easier. So finding 75%, 3/4 of something, that's the same thing as dividing it by 4 and timesing it by 3, isn't it? So 0.75 as a fraction is 3/4. Okay, so what I'm actually going to be doing is I'm going to be taking this number 16,000, I'm going to be timesing it by 3, dividing it by 4, timesing it by 3, dividing it by 4. I think that's what I'd rather do. Oh, but 4 times 4 is 16, so that might be easier. So that's because that goes into 16,000 quite neatly, doesn't it? So that's 16,000 times 9/16. Okay, so that's super easy. So then I can divide my 16 into 16,000 to give me 1,000. And then 1,000 times 9 is going to be 9,000, isn't it? Okay. Oh, show it? Yes, I did. It came out to be 9,000. Part B says Amelia sketches a graph to show the expected value of her car as it gets older. So she's got a linear graph here, hasn't she, with the value of the car falling in even increments each year. So explain how you would know that Amelia's graph is incorrect. Well, yeah, we'd be expecting some sort of exponential curve, wouldn't we? Not a linear curve. So I'm going to write down her graph is a straight line when the function is not linear. Part C says Amelia assumes that her car will have no value at all after 20 years. Explain why her assumption is mathematically incorrect. So we have a look at what her graph would actually look like. It's going to, rather than a straight line, it's going to look more like this, where it falls a lot in the first few years and then kind of tapers off. And actually, because you're multiplying through by a fraction each time, you're never actually going to get to 0. So the graph never touches the x-axis, so cannot be 0. Obviously tends to 0, but it will never actually be equal to 0. Question 12a. Write 5 6 as a recurring decimal. Okay. Well, I'm going to work this out using short division. I'm going to write 5 divided by 6. But to get the recurring decimal point, I'm going to just write a few extra zeros on the end here so I can start seeing what the pattern is. Okay, so 6 goes into 5 how many times? Well, it doesn't, does it? It goes in 0 times. So I'm going to have to carry that 5 over into the next column. 6 into 50, how many times is that? So 8 6s are 48, aren't they? So it goes in 8 times. Oops. 0.8. And 8 6s are 48, so that's a remainder of 2. So I'm going to carry 2 over into the next column. 6s into 20. 6, 12, 18 goes in 3 times remainder 2, doesn't it? So I'm going to write the 3 up here. 3 6s, 18. 20 from 18 is 2. And you can see after that, it's just going to keep repeating it, isn't it? Because I've got 6 into 20 again, which is going to be 3 again, and it's going to leave a remainder of 2 again, which is going to be 3 again, and so on. So I'm just going to get a bunch of 3s after that going on forever. So my number as a recurring decimal is going to be 0.83. What's repeating? The 3's are repeating, so I'm going to do a little dot on the 3. 0.83 like that. Okay, now the next one says convert 0.126 reoccurring into a fraction. Give your answer in its lowest terms. Okay, let's say x is equal to our recurring fraction then, or a recurring decimal. 0.126 reoccurring, so that's lots of 6's then, on forever. Okay, now to get rid of all those recurring 6's, I'm going to multiply it by 10, so I get 10x. 10x is equal to, well, it's going to be the same digit shifted one along, isn't it? 1.2666666, and so on. Okay, now you can see that these cancel each other out, don't they? So all those ones down there are going to cancel all those, and I'm left with 1.26 take away 0.12. Okay, so what's that then? 1.26 take away 0.12, that is 1.14. And 10x take away x is 9x. So 9x is 1.14. So what's that? X is equal to 1.14 over 9. Okay, that's almost a fraction, isn't it? If I multiply top and bottom through by 100, that's going to give me x is 114 over 900. Okay, so now I've got a fraction. I just need to try and get it into its lowest terms now. And any common divisors? Well, they're both even, aren't they? So I can halve them both. So half of 114 is 57 over 450. Any more common factors? Both of those, 5 plus 7 is 12, which is in the 3 times table, and 4 plus 9 is 9, which is in the 3 times table. So they're both divisible by 3. 3 is into 57. 19, 3's into 450, 150. Okay, is that it? 19 is prime, isn't it? So I think that's about as far as I'm going to get. Yeah, 19 over 150. Question 13. The graph shows information about the speed of a vehicle during the final 50 seconds of a journey. At the start of the 50 seconds, the speed is k meters per second. The distance travelled during the 50 seconds is at 1.35 kilometers. Work out the average speed of the vehicle during the 50 seconds. Give your answer in meters per second. Well, average speed is just distance travelled, total distance travelled, divided by total time taken. So we can see from both the graph and also from the question that the time taken was 50 seconds, so that's going to be my divisor, 50. So we know the distance is 1.35 kilometers. There's 1,000 meters in every kilometer, so 1.35 kilometers is going to be 1,350. Okay, so I've got 1,350 divided by 50, so I'm just going to cancel those zeros out. 135 divided by 5. Divided by 5 is the same as doubling it and dividing by 10, so 135 times 2 is 270, and then divided by 10 is 27, isn't it? So it's going to be 27 meters per second. And the second part of the question, we need to find out what the value of k is, which is this speed up here, isn't it? This is k. So we need to find that value there. Okay, how might we do that? Okay, well, we know that the total distance travelled is 1.35 kilometers, or 1,350 meters. And distance travelled in a velocity time or a speed time graph is the area under the curve. So this space in here is going to be 1,350 meters altogether. That space under the curve. Now this space under the curve you can divide up into two distinct areas. You've got like a rectangle part and a triangle part. Oops. So if I put a line in there. So area of a triangle, area of a rectangle. So the area of the triangle is half base times height, isn't it? So this bit in here is going to be 1/2 of the base. 40 to 50 has got a base of 10 times the height, which is k. In other words, it's 5k. And the rectangular part is just base times height, or length times width. So the base there is 40 and the height is k. So this is going to be 40k. Okay? So altogether, then our total area is going to be my 40k plus my 5k. And that is equal to 1,350 meters. Okay, so 40k plus 5k, that's 45k. Okay, so then to find k, I'm just going to divide both sides then by 45, and that should tell me what k is. Divide by 45, divide by 45. 45's into 1,350, that's not so nice, is it? But 45 is half of 90. If I can just double top and bottom, make that 90, make the top one 2 lots of 1,350, that's 2,700, isn't it? I can cancel that with that, and then I've got 270 divided by 9 then. 9's into 270, 9's into 27 go 3 times, so k then is going to be 30. Okay. Part C, calculate the gradient of the graph in the final 10 seconds of the journey. So we've got that triangle. So the height of this triangle was the value of k, wasn't it? It was 30, and the time taken along the bottom was 10. So then the gradient of this line is going to be change in y, which is 30, divided by change in x, which is 10. Well, it's actually going to be minus 30, isn't it? Because it's sloping down. So it's going to be negative 30 over 10, which is minus 3. So the gradient is negative 3. Part 2 says describe what the gradient represents. Okay, well, the gradient of a speed time graph is the rate of change of speed with respect to time. And the word we use for the rate of change of speed is acceleration, not ACE. Acceleration. So 2 marks though. Can't just be 2 marks for one word, surely. Well, what else might they want us to state? Well, we know it's acceleration. What about the units? What is the unit? So it's acceleration in meters per second, or ms to the -2. So it represents acceleration in meters per second. Question 14. Adam has 10 sweets in a bag. 5 are cherry sweets, 4 are lemon sweets, and 1 is an orange sweet. Adam chooses a sweet at random from the bag and eats it. He then takes another sweet at random from the bag and eats it. Adam says the probability that I choose 2 cherry sweets is 25 over 100. He is incorrect. Explain his error. Okay, well, the probability of selecting a cherry sweet then on the first pick. How many cherry sweets are there? There are 5. And how many sweets are there altogether? There are 10. Okay. So I assume what he's done then is he's multiplied that twice over, then it multiplied by itself. So 5 over 10 for the first selection and 5 over 10 for the second selection, giving you 25 over 100. Okay, but the mistake he's made is with this second selection, isn't it? He's assumed he has assumed it is independent. But actually it is dependent probability, isn't it? So that second selection is dependent on the first. What it should have been, probability of cherry is actually, yeah, that should say cherry as well, shouldn't it? So probability of cherry is actually going to be 5 over 10 for the first selection, and then on the second selection you're going to have 1 less cherry in the bag because you've eaten one, and you're going to have 1 less sweet in the bag because you've eaten one. So there's actually 4/9 in the second selection. So that's going to give you a probability of 20 over 90. Okay, so that's where he's gone wrong. So he's got 1 less sweet in the bag on his second selection. It's going to affect the probabilities. Okay, so find the probability that 2 sweets he chooses have different flavors. Okay, just going to get an overview of this by drawing a quick tree diagram. So we've got first selection, which is cherry, lemon, and orange. And then my second selection, again, cherry, lemon, orange, cherry, lemon, orange, cherry, lemon, orange, then haven't I? They're my 9 possible outcomes. So we want the probability that the 2 sweets he chooses have different flavors. Okay, so there are 6 outcomes, aren't there, that are different. You've got cherry lemon, cherry orange, you've got lemon cherry, lemon orange, or you've got orange cherry, orange lemon. They're the 6 choices. That seems like a lot of work. It'd be quicker to work out the choices where they're the same and subtract it from 1, I think, because there's only 3 of those. So rather than working out the probabilities that they're different, I'm going to work out the probabilities that they're the same. So like that one, and that one, and then take it away from 1. So the probability then of different, that's going to be 1 minus the probability there that they are the same, which is 1 minus the probability of cherry plus lemon plus orange. Okay, so I've got to work out those 3 probabilities and add them together and then take it away from 1. Okay, so what are the probabilities here then? So the probability of cherry already worked out, didn't we? We know it's 5/10 and 4/9, giving us an overall probability of 20/90. Let me just write it down anyway. 5/10 times 4/9. And then lemon then is this root, so across the middle. So for lemon, you've got how many lemon ones? 4 lemon to start with, so that's 4/10. And then you've got 1 less lemon and 1 less sweet, so that's 3/9, isn't it? So 4/10 times 3/9. And then orange, well, I've just noticed you've only actually got 1 orange, haven't you? So that's 1/10. So the probability then you're going to pick a second one is going to be 0. So actually that one just drops away. You don't have to worry about that one. It's 0. Okay. Well, maybe I'll just write that in. That's 0. No chance of getting orange. Okay. And then so just need to multiply those together, add them together, and then subtract from 1. So we already know the first one is 20/90. The second one is 12/90. Okay, so that's 32/90 altogether. So taking that away from 1, 32 from 90, that is 58. 58/90. Okay, that will do. Question 15. ICRA carries out a survey of 200 families in the north of England on their weekly spending on food. The cumulative frequency diagram summarizes the results. So we've got weekly spending on the bottom and cumulative frequency up the side. Part A wants us to find the median. So the median is the weekly spend of the middle person. Now I've got 200 people. Strictly speaking, I should add 1 and divide by 2. But with this sort of scale, it doesn't really matter. It's going to be, I might as well just use 200. So the 200th divided by 2, which is the 100th value. What's that equal to then? The median is going to be what I get from the 100th value, or from the 100th person. So from my graph, I'm going to find 100. I'm going to read across and read down, and that will be my median. Oh, come on ruler, do 90. There we go. Okay, that's a nice number. It's just landing on 85, I think. No, it isn't. It's 90, sorry. So halfway between 80 and 100, isn't it? So it's 90. So the median is 90 pounds. Okay, so that's 90 pounds. And then the second part wants the interquartile range. So the interquartile range is the value of the person a quarter of the way through and 3/4 of the way through subtracted from each other. So if I've got 200 people and I divide that by 4, again, really should be adding 1, but with 200 it's not going to make a lot of difference. So it's going to be our 50th value. That's Q1, isn't it? Okay, so Q1 is going to be reading across from 50. So where's 50? 50 is halfway between 40 and 60, isn't it? There. So reading across to the curve and changing direction. Reading down. So that is going to be my Q1. That was Q2, the median, wasn't it? So Q1 is, what was that on the scale? So we've got 5 divisions between 10 units, and each one of those is worth 0.2. So I think that one is pointing at, it's either 78 or 77. I think I'm going to go for 77. I'll read that as 77. Q3, that's going to be is 200 divided by 4 and times by 3, then isn't it? It's going to be the 150th value. So we're going to read across from 150 then on our scale. So 150 halfway between 140 and 160. So read across to the curve, change direction, read down. I think I read that as bang on 100. So that's Q3. So Q3 is 100. So therefore then the interquartile range is going to be equal to Q3 subtract Q1, which is 100, take away 77, which gives me 23. Icarus says 15% of these families spent over £120. Is her statement correct? State the evidence you have used in making your decision. So have 15% of these families spent over £120. Okay, so I think we can use the top 15% here, can't we? So what we're looking for then is the top 15% of 200 people. Now 15% of 200 is 30, isn't it? So it's 30 people. So 30 people down from 200 is, we need to look across at 170, don't we? So let's get the ruler out. So 15% of 200 is 30. So 30 down from 120. What does that give me? Move across to the graph. And read down. What's that then? That's 112, which is a bit lower than what she thought, isn't it? So you can say that the top 15% spent over £112. I suppose it's true that they must... No, it can't be true then that they're over 120, because some of those are going to be spending less, aren't they? So how can we write that down? I think we can say that the top 15% spent over £112. Oops. £112. So she is incorrect. Okay, and then part C says, in a survey of 200 families in the south of England, the median weekly amount spent on food was £84 and the interquartile range was 28. Make two comparisons between the weekly amount spent on food in the north of England and the south of England. State the evidence you've used to make your comparisons. So we've got an average value and we've got a measure of dispersion for both groups. So we're going to compare like with like. We're going to compare the averages, the median averages for the two areas of the UK, and then we're going to compare the two interquartile ranges to give us an idea of dispersion. So let's compare the averages first. So the average in the north of England was 90 and in the south it was 84. So we can say that on average, families in the north spent more on food, and that was £90 versus £84, wasn't it, for the medians? Okay, so we've compared the averages and we've said the families in the north spent more on food. Then the ranges, or the interquartile ranges. Okay, so it's a much smaller value for the south, which means that they are much more similar to each other than the north. So we're going to say that there is much greater variation in spending, not is spending, in spending by families in the north. And then we got that from interquartile range. Okay, so that's my evidence. So we compared the interquartile ranges and we can say that there's much greater variation in the families in the north. Okay. Question 16a, write root 12 plus root 75 in the form k root 3. Okay, so let's just break these two down first. So what's root 12 the same as? We can say that root 12 is the same thing as root 4 times 3. I'm looking for factor pairs of these numbers where one of them is a square number, which is why I picked 4 and 3, because that means I can break this up into two separate roots. Root 4 times root 3, and the square root of 4 is 2. So I can say that's the same thing as 2 root 3. And then 75, doing the same thing with 75. We can say that 75 is, well, again, we're looking for a factor pair where one of the pair is a square number. So we can pick 25 times 3 then. That's 75, isn't it? And then we can break that up into two roots, and the root of 25 is 5. So that's 5 root 3. Okay? So our sum, root 12 plus root 75, is the same thing as 2 root 3 plus 5 root 3, which is the same thing as 7 root 3. So that's my answer. Write 12 root 3 plus 7 root 3 in the form of something root 3, which I've done. It's 7 root 3. Okay. Next, work out 16 to the power of negative 3/4. Now, negative 3/4. This is quite a complex index, minus 3/4. But I take each one of these as 3 separate steps. So I've got a negative sign, I've got a denominator, and I've got a numerator. And I'm going to deal with them as 3 separate operations. Okay, so first off, the negative sign. A negative index means 1 over that thing. So rather than having 16 to the power of negative 3/4, I'm going to deal with the minus sign and say that's the same thing as 1 over 16 to the power of 3/4. Okay, so I've dealt with 3/4. So I've dealt with one of the bits, haven't I? So now let's look at this number on the bottom, the 4 there. That means the 4th root of 16, isn't it? So the 4th root of 16, it's got to be 2, isn't it? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is going to be 2. So that's the same thing as 1 over 2 to the power of 3. So I've dealt with the negative sign, I've dealt with the denominator. Now I just need to deal with the numerator of that index. So power 3, 2 to the power 3, 2 cubed. And that's just going to be 1 over 8. So it's 1/8. Okay, so these complex indices, just break them down into 3 separate steps. Do one after the other. Okay? Question 17. Solve the inequality x squared minus 5x minus 6 is less than or equal to 0. Okay, so I think first off we need to factorize this, don't we? So let's say that's the same thing as 2 brackets multiplied together. So I've got x at the start, x squared, so I'm going to have x and x here. Now let's have a quick look at the constant at the end, negative 6. What are the factor pairs of 6? 6 has factor pairs 1 and 6, 2 and 3. So they've got to be one of my numbers, and we're looking for a factor pair that adds up to -5. Okay, so but remember, one has to be positive and one has to be negative. Like 2 and 3 adds up to 5, but we're actually going to be having one positive and negative one. So I actually think the one we're looking for is this pair here, the 1 and the 6, isn't it? So it's going to be +1 because and -6. That's going to give me -5 in the middle, isn't it? Okay. Now, if this was an equation, it would have roots then at -1 and +6 then. So if I was going to draw a sketch of this quadratic, all quadratics have this kind of parabola shape, don't they? Okay. And then this particular parabola is going to have 2 roots, which we've just kind of worked out, haven't we? So the one on the left, x plus 1, that's going to give you a root of -1, and x minus 6 is going to give you a root of 6. So this graph is going to look something like this. So where would the y-axis be? Doesn't really matter. Be somewhere in between. Now we want to know when this function is less than 0. So what sections of the number line for x is this graph negative? Okay, well, it's below the axis in this section from here to here, isn't it? Okay, on the other sides, here it's above the axis and here it's above the axis. So it's just those bits between -6 and 6 where this function is below the x-axis or negative. Okay, so the region we're looking for is the region between -1 and 6. So x then lies between 6 and -1. Now I do recommend that you do a sketch like this, because otherwise it gets a bit confusing, and I know many students make mistakes with it. So I do recommend drawing the parabola, working out where the roots are, and then thinking, where is that graph greater than or less than 0? I think that's the smartest way of doing it. Okay, so that's my range. X lies between -1 and 6. Question 18. Prove that the difference between two consecutive square numbers is always odd. Okay, so we need to do this algebraically if we're going to make a proof. So let's take a number n, and if we square it, then that's going to give us our first square number. Now, what would the next consecutive square number be? So let's say I had 2 and I squared it and I got 4. So 4 would be my first square number. The next square number would be one more than 2. It would be 3, wouldn't it? 3 squared is 9. Okay, and I would get that by taking my value n, adding 1 to it, and then squaring it. So my two consecutive numbers are n squared and n plus 1 all squared. Okay, so these are my consecutive numbers. Okay, n and n plus 1 all squared. Now we want the difference of these numbers. Difference in maths means subtraction, doesn't it? So basically what I'm doing is I'm taking one of these away from the other one of these. So the difference is going to be n plus 1 all squared minus n squared. That's going to be the difference, isn't it? Okay. Now let's have a look at that brackets. If I square something, I'm timesing it by itself, aren't I? So that's n plus 1, n plus 1. And then doing FOIL on that bracket, n times n, n squared. 1 times n is 2n, and 1 times 1 is 1. Okay, so that gives me n squared plus 2n plus 1. And then I've got that minus 1 from there. So that one and that one are going to cancel it out. And that is going to leave me with 2n plus 1. So the difference is 2n plus 1. So if you think about it, if you pick a number and you times it by 2, 2n is always an even number, isn't it? So then if you add 1 to it, you're going to get an odd number. So I'm going to say 2n is always even. So 2n plus 1 is always odd. Okay, that's it. All done. Question 19, solve these simultaneous equations algebraically. We've got a quadratic and a linear equation. So we can't solve these by elimination. It's going to have to be done by substitution. Now you notice that I've got a y here and a y here. So these two expressions are actually equal to each other, aren't they? So I can equate this bit here with this bit here. Okay, because they're all equal. So I can say that 2x squared minus 7x plus 4 is equal to 4x minus 1. Okay, so then we're just going to bring everything to one side. So if I subtract 4x from both sides, it's going to give me 2x squared minus 11x plus 4 is equal to minus 1, and then add 1 to both sides. 2x squared minus 11x plus 5 is equal to 0. Okay, so I've got a quadratic in x squared. Let's see if we can factorize it. Okay, now notice I've got a 2x squared on the front, so I'm going to have a 2x and an x if it factorizes. On the back I've got a 5, so I'm going to have factors 1 and 5 of that because it's prime. They're the only factor pair you can have. Notice it's positive at the end and negative in the middle, so it's going to be minus minus. So if I put 1 and 5 in these brackets, can I get minus 11 out of it? I can if I put the 5 here, because then 2x times the minus 5 is going to give me minus 10x, and the 1 times the x is going to give me 1x, and 10x 1x is going to be 11x. So that kind of works out, doesn't it? So if 2x minus 1, x minus 5 is equal to 0, then that means that x has to be a half, or x is 5. Okay? So they're my two values of x, half, and 5. Don't forget though, we need to find the values of y too. So it's easier to take the easier or the smaller, or simpler of the two original equations I was given. So let's take y equals 4x minus 1. So when x is a half, y is going to be 4 lots of a half minus 1. 4 halves are 2, take away 1 is 1. So y is 1 when x is a half. And when x is 5, y is going to be 4 lots of 5 minus 1. 4 5s are 20, take away 1 is 19. So I get half goes with 1 and 5 goes with 19. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.